Hi, my name is Nitsan Gadish and I'm an Applications Engineer for Analog Devices MEMS and Sensor Technology Division. I'm here to talk today about the ADXL362, which is a breakthrough ultra-low power MEMS accelerometer. What I'm going to talk today about is the ultra-low power consumption of the accelerometer at the device level, and I'm going to compare it to a competitive device. So what I've got here on the monitors are two demos. On this side, I show the 362 output, and I can measure power consumption on this GUI as well. And on this side, I've got a competitive device, and again, I can make the same measurements with that. So let's take a closer look at the power levels. Let's first take a look at the power consumption of the ADXL362. I've got the 362 running here at 100 Hz data rate, and I've got the screen showing the current consumption here at the top and just real-time output here at the bottom. So we can see at 100 Hz data rate, XL362 is consuming about 1.8 microamps. If I bump the data rate up to 400 Hz, my current consumption comes up a little bit to just over 3 microamps. And at the lower data rates, so 12.5 Hz, current consumption comes down closer to 1 microamp, right around 1.4. On the competitor product, to achieve similar current levels of around a couple of microamps, I need to knock the data rate down to 10 or even sub 10 Hz. So at 10 Hz, I'm looking at an average current level of about maybe 3 microamps. If I knock it down to 1 Hz, the current level is lower, but now I'm only getting one sample every second, so it's going to be pretty easy to miss certain motions. At the same data rate I was looking at before, so at 100 Hz data rate, on this competitive part, the power levels jump up to right around 20 microamps. And for an even more useful data rate of about 400 Hz, now I'm looking at just under 70 microamps. Now, there are applications where low data rates are useful, but the ADXL362 addresses this as well. We've got a motion-activated wake-up mode in which the part samples acceleration about 6 times per second and consumes an average of about 300 nanoamps. So again, the ADXL362 offers much lower current consumption at the same bandwidth, or a much wider bandwidth at the same current consumption. A win-win. To learn more, please visit analog.com/ADXL362. Thanks for watching.